This video is Trig Notes 3.2. It's going to cover the law of cosines and Heron's area formula. The law of cosines is a formula that will help us find missing sides and missing angles of triangles that are oblique. But the difference between the law of cosines and the law of sines is that we're not going to be given that angle side opposite relationship that we were when we have the law of sines. So here is the formula. There's actually three different forms of the formula. There's this form when you're trying to find side A or you're trying to find angle A. Then there's this form, and this would be useful if you're trying to find side B or find angle B. And then finally there's the third form if you're trying to find either side C or angle C. So let's take a look at an example of how we would use this. And again, you have to pick which one of the three forms you're going to use. Okay, so if we draw a triangle, label it A, B, and C. Angle A was 55. Side B, which would be across here, this would be side B, would be 3. And side C, which would be across from angle C, would be 10. So then this has to be side A, sorry. What are the things that I need to find? It looks like I need to find angle B and angle C, and I also need to find side A. So it's a good idea to keep in mind what we're trying to find. So looking at this, I know angle A, but I don't know side A. So I don't have that angle side opposite relationship, so I can't use the law of sines. But because I do know angle A, this top form of the formula is the only form that has angle A in it. So that's the form that I have to use. So plugging into this form, we would say that A squared equals B, which is 3, squared, plus, again I'm just following this form here, C, which is 10 squared, minus 2 times 3 times C, which is 10, times the cosine of A, which is 55. So because I'm trying to find A, I can really type all of this into my calculator just like this if I make sure that my calculator is in degree mode. So when I do that, I would get A squared to be equal to 74.585, and it keeps going on and on. I'd want to keep that answer in my calculator so that when I try to solve for A, and I'm taking the square root, I'm going to get the correct value. I would find that A would be equal to 8.6. So now that I know all three side lengths, I have a decision to make about which angle I want to find next. And here's an important piece of information to remember about using the law of cosines. What's nice about the law of cosines is you never have to check for the possibility of two different triangles, like you have to when you use the law of sines. So in this problem, my largest angle should be angle C because it's across from the largest side. So I recommend when you do the law of cosines, when you find your angle, to always try to find the largest angle first. And you really can only do that once you know all three side lengths. So again, keeping this in mind, finding the largest angle first out of between B and C, C would have to be what I'm finding next. And so to find C, I'm going to want to use this version of the formula. So I would say C squared, which is 10, is equal to A squared, 8.6 squared, write that a little neater, 8.6 squared, plus 3 squared minus 2 times 8.6 times 3 times the cosine of C, which is what I'm trying to find. Now, here's where you're going to make a mistake. In this part of the problem, we could just type everything in the calculator. I can't just type everything in the calculator and then just put the cosine of C after that. So what I'm going to want to do is kind of do this in a multi-step way. Do 10 squared, that's going to give you 100. Then you can actually do these two pieces together. When I do 8.6 squared plus 3 squared, I end up getting 82.96. Then I want to just do these three pieces together. Negative 2 times 8.6 times 3 is going to give me negative 51.6 cosine of c. A common mistake that students will do is they'll try to subtract these two from each other. You can't subtract these two from each other because this has a variable with it. It has the cosine of c. So the next step in solving is to move over this 82.96. And again, I see it happening all the time, is that they'll look at this and they'll try to get a number for all of this and then times it by the cosine of c, and you just can't do that. So when I subtract this to move it over, I end up with 17.04 equals negative 51.6 cosine of c. Get rid of the negative 51.6 by dividing, and I end up with negative 0.3302 being equal to the cosine of c. Again, I don't want the cosine though, I want just the sine, or excuse me, I want just c, so I've got to move the cosine away by taking the inverse. So when I type that into my calculator, I end up getting angle C to be equal to 109.3 degrees. Now that you know what that angle is, you can find angle B just by subtracting from 180. So 180 minus 55 minus 109.3 would end up giving me 15.7. So again, what's nice about the law of cosines is you don't have that option of having two different triangles where you have to check. Even though this was an acute angle, I don't have to worry about the possibility with the law of cosines of having two different triangles. And again, that's an important reason why you want to find the largest angle first, because I know that my triangle cannot have another obtuse angle in it. So these would be my answers. Okay, let's take a look at our next example, where we have, again, another triangle. We'll call it A, B, and C. This time I'm only given information about side lengths. A was 8, B is 19, and side C is 14. So I need to know all three angles. I need to know angle A, I need to know angle B, and I need to know angle C. Now remember, I said when you do this, try to first find the largest angle. And in this problem, the largest angle has to be, since B is the largest side, would have to be B. So we want to find B first. So that means then, if I'm trying to find B first, I have to use this version of the formula. So let's go ahead and do that. So B squared, which is 19 squared, equals A, 8 squared, plus C squared minus 2 times A times C times the cosine of B. So again, let's when we simplify this, let's figure out what 19 squared is. 19 squared is 361. Doing this, 8 squared plus 14 squared, I get 260. And then doing this, negative 2 times 8 times 14 gives me 224 cosine of B. Don't make the mistake where you try to subtract these. You're not going to be able to do that. Subtracting the 260, I'm going to end up with 101 equals negative 224 cosine of B. Get rid of the negative 224 by dividing by it. So 101 divided by negative 224 gives me negative 0.45089. But that's what the cosine of B is equal to. And again, I'm trying to solve for angle B, so I move the cosine over by taking the inverse. And again, if I didn't mention this earlier, you're going to want to make sure your calculator is in degree mode to do this. I'm going to end up with angle B being equal to 116.8 degrees. Again, that's my largest angle. I can't have another obtuse angle in this, this problem. So, moving on to another angle. Now that I know that B is 116.8, if I want to, I can use the law of sines because I have an angle side opposite relationship. And I don't have to worry about the possibility of two different triangles because I know that I can't have another angle that's bigger than 116. So I'm going to actually use the law of sines to help me find my next angle. So I'm going to say the sine of 116.8 over 19. And I'll find, let's see, C should be my second biggest angle. I'll find that one next. The sine of C over 14. So cross multiply. Cross multiply. And we would end up dividing by 19. So 14 sine of 116.8 divided by 19 gives me 0.65769. Again, I don't want the sine of C, I want just C, so I have to take the sine inverse of that. 41.1 degrees. That was angle C. And then finally, to find angle A, I would take 180, subtract the 2 that I know, and I would get 180 minus 116.8 minus 41.1, 22.1 degrees. So take a second to ask yourself, largest angle across from the largest side? Yes. Angle C, which was 41.1, is my second largest angle, and it's across from my second largest side. And this was 21.1, and it's across from my shortest side. So it ends up working out. Okay, the next problem we're going to talk about is now finding the area of a triangle, and we're going to use Heron's area formula to help us do this. We can use this formula if we only know the three side lengths of a triangle, and it's a non-right triangle. So here's what the formula says. The area is equal to S times S minus A times S minus B times S minus C, and then I take the square root of all of that. And S is equal to all three side lengths divided by 2. Add up all three side lengths and divide it by 2. So let's first find S in our problem. Here are my side lengths. 14 plus 21 plus 27 divided by 2. That's going to give me an S of 31. So now using my formula for area, I'll do S, 31, times 31 minus A, we'll call this A, we'll call this B, this C, times 31 minus 21 times 31 minus 27. So plugging this in, I'm going to end up with, if I multiply all of this together without the square root formula at first, I'm going to end up with, or without the square root, 21,080. And when I take the square root of that, I end up with 145.2, and I was given units as centimeters squared. So really what Heron's area formula allows us to do is to find the area of a triangle when I don't know any angles, and I just know three side lengths. So I wouldn't be able to use previous examples where we talked about area equals 1/2 base times height. I wouldn't be able to use previous examples where we talked about using half of A times B times the sine of C, because I don't know any angles. And here I don't have a base and a vertical height. So again, Heron's area formula helps you find the area of triangles when you know three of the sides.